In this module, we are going to talk about UDP services. So, the first service which UDP provides is process-to-process communication. What is process-to-process communication? You have studied about sockets, right? Socket is a combination of IP and your port numbers. Okay, and your port numbers. So UDP uses this socket programming which enables process-to-process communication. Okay. Now this table shows us some of the well-known ports which is used with UDP. Okay. There is one more application which is the most used, that is domain name service. Okay, this inherently uses UDP. Okay, why? Because this is a short request. This is a short request and response application, right? This is short request and short response application. Therefore, it makes use of UDP. So there are bunch of applications which actually uses UDP. We are going to talk about this in next module. Okay, so now beginning from the beginning, I'm telling that UDP is a connectionless service, right? Now, what actually I mean by a connectionless service? So before that, let me tell you about connection oriented service. What is a connection oriented service? So TCP is a connection oriented service. So by using this protocol, how actually a file is sent? See here, suppose this is a sender and this is a receiver. Suppose there is a file which has to be sent from sender to the receiver. So how the file is sent? First of all, sender is going to send an request. Okay, this is a request to the receiver that I want to send something. Again, the receiver is going to reply to your request. Again, there will be an acknowledgement. So basically, this is the establishment of your connection. So you are taking 3 packet itself to just establish a connection, and after that there is something known as data transfer. After this establishment, you will be doing your data transfer, and once your data is exhausted, you will be sending in data termination or the connection termination request to the receiver. So this is then connection oriented service. Okay, TCP is an connection oriented service. This is how connection oriented service works. But in case of UDP, which is an connectionless service, how an file would be sent from sender to receiver? If there is any file which has to be sent, it is not going to establish connection, and after that do data transfer. All those steps will be skipped here. Instead, whatever file a sender has to send to the receiver, it is directly going to send that packet itself, or the data user datagram. It is going to send to the receiver. It is directly sent to the receiver. Okay. Now, flow control is not provided by UDP. Okay, because it does not contain any window mechanism. What is a window mechanism? You will be studying in TCP. Okay, in the next chapter, that is TCP. Okay, that is transmission control protocol. Okay, now it also does not have any error control. Okay, but you have studied about checksum, right? In the header file, you have one component known as checksum, right? Other than this, it is not able to it is not going to do this error control part. Okay, now we are going to study about checksum. Okay, now we are going to talk about checksum. Okay, so checksum in UDP header is of 16 bits, right? See here, checksum is of 16 bit in UDP header. And on what basis is this checksum calculated? So it is calculated on UDP header plus the data which is present, and there is something known as pseudo header. Okay, there is something known as pseudo header. So on these 3 components, you are going to check your you are going to calculate your checksum. You can use the that is CRC, that is cyclic redundancy check. Okay, this is one of the types of checksums. Okay, now we are going to talk. See, we know about UDP, what is an UDP header, what is the data, but we don't know about what is pseudo header. So we are going to talk about pseudo header over here. Okay. Now what is a pseudo header? See, this is the format of pseudo header. How actually it looks like. See, first of all, it has a 32-bit source IP address. It also has 32-bit destination IP address. This is as same as the values which is present in the IP header. IP header consists of, it also consists source IP address. It also consists of destination IP address. There are some values from, there are some components from IP header which are taken and just placed in your pseudo header. Okay, like the source IP address, destination IP address, this protocol. See, this is the protocol one. All zeros is, this is reserved. Okay, this is reserved. Okay, this there are 2 to 3 components which are present in this pseudo header. Now, why actually do you need this? See, actually you are writing this data twice, right? Twice. Why do you want this? Just for the purpose of double checking. What double checking? See here. See, suppose you are in sender, there is an receive. It has sent some data, and that receiver it has received. At network layer stage, it is going to decapsulate, right? And it is going to throw this IP header, remove this IP header. Now at after that it will be passed to the transport layer. Transport layer, we have, I'm going to again check whether is this, sorry for this. Okay, at transport layer, again, just to be double sure that this packet belongs to me. Okay, this receiver is going to be double sure about this thing, then only it is going to pass to the application layer. Okay, this is the double checking process over here. So first of all, at this at this network layer, the IP header is going to check its source IP address, destination IP address using its checksum. Again, it will the same will be passed uh, to the transport layer. In order to in order to check the source IP address, destination IP address, you have there must be some there must be value of this source IP address, destination IP address present, right? So in order to keep these values, we are going to make use of this pseudo header. Okay, at transport layer. Okay, now this is the sole purpose of using this pseudo header, and on this we are going to, and on these 3 components we are going to calculate our checks. See, now this this calculation process is time consuming, right? Obviously this is time consuming, right? Therefore our UDP has kept this optional, this part as optional. It is not mandatory to give checksums. Okay, because UDP always relies on speed. Okay, it is not going to do anything that is going to consume your time. Okay, therefore checksum, as checksum is time consuming, right? Checksum is time consuming, therefore in UDP it is kept as optional part. Okay. Okay, so the next point is congestion control. TCP does not provide congestion control. Why? Because it inherently assumes that the packets which it is going to receive is small in size, right? The short request response, right, which I talk, that is, those packets are small in size, right? Therefore this packet cannot contain, this cannot produce any congestion, right, in your network. If there is no congestion, there is no point of congestion control itself, right? Now the next service is encapsulation and decapsulation. Okay, this can be understood easily by this diagram. See, this is the sender process. See, this is some data. Suppose this is some data, and this is the application layer, right? Now this data from application layer is being provided to the transport layer. This is the transport layer. In transport layer, you are going to make use of UDP, that is user datagram protocol. In that datagram protocol, you will be just appending your UDP header towards with the data. Okay, and that data would be passed to the network layer. Now the same data would be appended with the IP header now, and after that you are going to pass it to the data link layer. Your data link layer uh, is going to add its frame and some trailer to your IP packet, and it becomes a frame. Now that frame will be converted to signals and passed through the physical layer, and it is going to reach the receiver. This is the destination or the receiver. This was the sender, right? At receiver, at receiver, the decapsulation phase starts. At decapsulation phase, first of all, this is the data link layer. It is going to remove it is just going to drop its header and the trailer part, and it is going to pass it to the network layer. Network layer is going to do some checksums which is present in its IP header, and if the whole data is correct, then it is going to just drop its IP header and it is going to pass to the transport layer. At transport layer also, it is there is one checksum. If it is present, it is going to calculate the checksum and check for the data, and if this data is corrupted, it is going to silently discard it. This is also one of the reasons why congestion doesn't takes place at when you are using UDP. Okay, your data packet, if it is not correct, if it is not correct, then it has been silently discarded. It means your receiver does not know that this data has reached or not. Okay, and if it is correct, it will be passed to the application layer, and from there it will be given to the receiver's process. Okay, this is how encapsulation and decapsulation takes place. Now, okay, the next service which UDP offers is queuing. So queuing is, see, first of all, you know that each process is associated with an port number, and each port number is associated with an queue. Now there are two methods in which you can implement this queue. Is So the first one is that you have only one incoming queue. The second method is you have one incoming queue and you have a separate outgoing queue. See, let me show you the diagram. See, in this diagram, this is the client side and this is the receiver side, right? Or the server side. At this each side, you can see two queues. That is, one is for incoming queue, one is for outgoing queue. Same as for server side. Okay. Now here we are going to see how actually queues work in UDP. Okay. Now, see, first of all, okay, let's see first of all the client's perspective, or the queuing from client side. Okay, this is the client side. Now whatever data whatever data or message that client has to send to the server, it will be sending through the port number which has been specified in the request. Okay, so that is 13. So it will be going through the outgoing queue. Let me change the color. Okay, so the request will be going through the outgoing queue itself. Okay, it goes from the outgoing queue. Then after going through the outgoing queue, it is going to reach the server. Okay, now suppose, what if this data overflows? If this queue overflows, in case of queue overflow, okay, when a queue will overflow when data is continuously coming from the application layer. Okay, when the data is continuously coming from the application layer, obviously the queue is going to overflow. Then in that case, your operating system is going to interfere. Your operating system is going to control the process that saying saying, hey, the queue is not able to process the whole thing. Okay, just slow down. Okay, your operating system makes it viable for you. This is how queue in UDP works. Sending while receiving from the server, it is going to it will be having its port number, right? Its destined port number. Now suppose that is 13. Now it will be destined to this. Now suppose at this point it reaches till UDP. It is going to check the port number. It is 13. If it is present over here, if its queue is present, right? See, for port number 13, a queue is present. Therefore, whatever data was sent by server, it was passed through the queue and at last passed to the process itself. Now, what if the server sends something port number 15? which is which is not present. Its queue is not present over here. Okay, in that case what happens is it is going to send an ICMP packet. Okay, what is ICMP packet? It is one of the task of ICMP is sending an error messages, right? Now it is going to send error message as port unreachable message. One of the error messages which ICMP packet sends is port unreachable, right? See, 15 port number from server to client was sent, right? Destination was 15, but at the client side you can see that 15 port number, queue for 15 port number is not present, right? Therefore, in that case you have to send an ICMP packet saying that port is unreachable. Okay, now let us see the perspective of client of the server. At the server side also you have two queues, right? One is the outgoing queue and one is the incoming queue. Whatever message the server has to send to the client, it will be going through the outgoing queue. Now the same rules apply to the server also, that uh, it is going to send a message from which it was requested. Okay, to that port number it is going to send the message packet itself. Now in case of receiving, it will be checking whether the queue for that respective port is present or not. If that port number, suppose port number was, see, for 52,000 port number is present, right? This is the incoming queue is present for this port. Suppose the sender has sent some request on port number 505, which is not present here only, whose queue is not present, right? In that case server is going to send an ICMP error packet saying that port is unreachable. Okay, now this was about the queuing in UDP. Okay.